Hi, this is Xiong-Fei again, here to talk about the functions of MATHLAB and its calculator mode. Now let's go to MATHLAB and let's go to calculator here. And you can just see from the different menu options that MATHLAB supports a variety of functions that we can compute here. For example, let's just go to factorial and let's enter an integer, for example 6. We find that 6 factorial is 720, as you would expect. And we can try out some of the different other functions in discrete math here. We can move on to probability. For example, let's just look at a hypergeometric distribution. Now let's just say that we have a bag and there are 20 marbles in the bag, and of those 20 marbles there are 10 red marbles. Now let's just say that if we draw 15 of the marbles, what is the probability that we're going to have exactly 8 successes? Now let's hit OK to find out, and we find that we have about a third of a chance of drawing exactly 8 red marbles from that bag. Now we can move on to different other distributions. For example, there we have continuous distributions here in the normal distribution, the student's t distribution, in addition to the discrete distributions that we have here, and the binomial, negative binomial, geometric, hypergeometric, and the Poisson distribution. And we can look at MATLAB's functions and its calculator, and its calculator mode here under calculus. For example, let's just look at our function. For example, should say that we look at the function sine x over x at a value of 0. Now geometrically, we can prove that this limit is going to evaluate to 1. And we find through MATLAB that in fact it does. Now let's try some other things. For example, we can find a derivative. Let's just say that we find the derivative of x squared at 1. We expect that this is going to return 2, and in fact it does. And we can also see that in this picture right here. Now let's look at the definite integrals. For example, let's just say that we're trying to find the integral of cosine x from 0 to pi. And we find that this integral is 0, as you would expect by looking at this picture over here, as the top area at the top cancels out the area of the bottom. Now let's look at some of the other functions here. For example, MATLAB also has a solve for 0 function. For example, let's give it an input of x squared minus 9 is equal to 0, and let's guess 20. We can pick almost any guess depending on the type of function that we have. And we find that this is going to evaluate to -3 or 3, depending on our initial guess. And since our initial guess is on the positive side of things, it's going to come out to 3. So we press enter, and we find out that it does come out to 3. Now the 0 function actually uses an algorithm called Newton's method, which utilizes calculus, and hence is why this feature is under the calculus mode. And we have other functions as well. For example, we have the gradient ascent here and the gradient descent here that we use to calculate local maximums and local minimums using those algorithms. And we also have definite integral functions. For example, our definite integral function actually uses Monte Carlo integration on a complex domain, which is not very accurate, but overall it still gets to the proximity of the answer to a good precision, depending on how we implement our algorithm. For example, let's just say that we want to find the area of a unit circle here. We're going to be integrating 1 over the domain of a unit circle, which is x squared plus y squared is less than 1. Oops, is less than 1 here. And we can skip all of these constraints for additional constraints that we could have for our other functions to describe a more complex domain. Let's describe a bounding box for this domain here, which is just a unit box from -1 and 1 for both x and y. And we press enter, and we're going to find that this double integral is our area of a unit circle is approximately pi, and we find that this numerical approximation method actually gets very close. We get to 3.1413, and pi is actually 3.14159. So let's try some different functions here. The definite triple integral works in a similar way as the definite double integral did. And we can try our vector calculus as well. We have a gradient, curl, divergence, and the Laplacian operators here for functions. For example, let's just say that we want to find the gradient of the function x squared plus y squared minus z squared at the point 1, 2, 3, for example. And this is going to find our gradient. I find that's 2, 4, 6, as we would expect from our knowledge of vector calculus. And we can come down here and do, there's also curl, there's also divergence. And similarly, we have local minimum and local maximum functions here that also use the gradient ascent and descent algorithm to calculate those. For example, if we click on local minimum, just say that we want to find the local minimum of a basic elliptic paraboloid, x squared plus y squared, and where you have to give it a guess again. Let's just say that our guess is going to be 3, 4, and our minimum is going to find that the minimum of this paraboloid is going to be 0, 0, 0, as we would expect. And that's all I have to say about the calculator mode. I hope that you guys get to play around with some of these various features I think are pretty cool, and have fun.